Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
At some point between 300 million and 1 billion years ago, a large cosmic object smashed into the planet Venus, leaving a crater more than 170 miles in diameter. A team of Brown University researchers has used that ancient impact scar to explore the possibility that Venus once had Earth-like plate tectonics. For a study published in Nature Astronomy, the researchers used computer models to recreate the impact that carved out Mead crater, Venus' largest impact basin. Mead is surrounded by two cliff-like faults, rocky ripples frozen in time after the basin-forming impact. The models showed that for those rings to be where they are in relation to the central crater, Venus' lithosphere, its rocky outer shell, must have been quite thick, far thicker than that of Earth. That finding suggests that a tectonic regime like Earth's, where continental plates drift like rafts atop a slowly churning mantle, was likely not happening on Venus at the time of the Mead impact. This tells us that Venus likely had what we'd call a stagnant lid at the time of the impact, said Evan Bjons, a graduate student at Brown and Studies lead author. On Earth, evidence of plate tectonics can be found all over the globe. There are huge rifts called subduction zones where swaths of crustal rock are driven down into the subsurface. Meanwhile, new crust is formed at mid-ocean ridges, sinuous mountain ranges where lava from deep inside the Earth flows to the surface and hardens into rock. Data from orbital spacecraft have revealed rifts and ridges on Venus that look a bit like tectonic features. But Venus is shrouded by its thick atmosphere, making it hard to make definitive interpretations of fine surface features. This new study is a different way of approaching the question, using the Mead impact to probe characteristics of the lithosphere. Mead is a multi-ring. That work showed that the final position of the rings is strongly tied to the crust's thermal gradient, the rate at which rock temperature increases with depth. The thermal gradient influences the way in which the rocks deform and break apart following an impact, which in turn helps to determine where the basin rings end up. When that deeper water cools down to similar temperatures as the surface, you get a thicker ice sheet. The calculations suggest that the gradient is far lower, and the lithosphere much thicker, than what you'd expect for an active lid planet. That would mean that Venus has been without plate tectonics for as far back as 1 billion years ago, the earliest point at which scientists think the Mead impact occurred. Several other ringed craters that the researchers looked at were proportionally similar to Mead, and the thermal gradient estimates are consistent with the thermal profile needed to support Maxwell Montes, Venice's tallest mountain. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.